Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Let us discuss today a number of problems using functions. So, let us start with the first program, that how to print a matrix in snake pattern. So, for example, you are given a n by n matrix, and in this matrix, you have to print the elements of the matrix in a snake pattern. So, let us look at this example. Suppose there is a matrix. So, it is a 4 by 4 matrix in this example. Now, you have to print the content of the matrix in this snake pattern. That means first 10, 20, 30, 40. Then coming to this order, then 45, 35, 25 and 15. Then coming to the next line. So, in a snake pattern, you have to print the elements of the matrix in this format. So, first the 0th row will be printed from left to right, whereas the first row will be printed from right to left. That means if you will understand the problem, then you will find that all the even number of rows are printed. If the row is even, then the elements are printed from left to right, whereas if the row is odd, then the elements are printed from right to left. So, whenever you will follow this ordering, then you will find that it will form a pattern that is called a snake type pattern. So, in each row, even and odd, the elements are printed. The even and odd patterns are printed in the opposite order. So, this pattern is called snake pattern. So, you can see the output. If you will observe the output, then 10, 20, 30, 40 are for the even row. Similarly, 45 to 15 are for the odd row. Then again, so it is in opposite order. Similarly, 27 to 48 is in even row and it is from left to right, and 50 to 38 the values are for the odd row and it is in the opposite pattern. So together it forms a pattern called snake pattern. So you can see another example where it is a 3 by 3 matrix. So in this 3 by 3 matrix, you can see the values are 1, 2, 3. First it will print 1, 2, 3. Then it will print 6, 5, 4. Then followed by it will print 7, 8, 9. So it will form this snake pattern. So you can visualize this through this diagram. So you can visualize the matrix. Elements are 10, 20, 30, 40. It is a 4 by 4 matrix. Then followed by 80, 70, 60 and 50. Then followed by 27, 29, 37 and 48. 50, 39, 33 and 32. So you can see here, this is the even row and this is the odd row. So this is 0th row, this is first row, this is second row, this is third row and so on. So how will you display the elements from using this pattern from even row and odd row? So for that, let us do this problem. So let us go for how to do this problem. Now let us move on to our Deb C++, your compiler. Now let us start how to print the matrix content. So for printing the matrix content, first start with the header file #include stdio.h, then followed by your structure will write down int main and return 0. So before going for solving this matrix, first read the content of the matrix. So for reading the content of the matrix, let us take a matrix. And if you want that you can define the rows and columns. So we can go for #define M is suppose 4 by 4 matrix I want to take. Then you can write #define N is 4. Okay. Now define a matrix of size M row and N columns. Okay. Followed by I and J are taken as the looping variables. So first read the matrix elements. So printf. So first enter elements into the matrix. So this is a message after writing this message. So how to read the elements into the matrix? For reading the elements into the matrix, it is M by N matrix. So there will be M rows, N columns. So we have to write down 2 for loops. So loop within loop we have to write down. For I is equal to 0. then I less than m. M is the number of rows, then I plus plus. Okay. Now inside this, write another for loop for j is equal to 0, j less than n, and then j plus plus. Okay. Now we will read the elements. So write down scanf statement. So scanf percentile d and matrix of ith row and jth column. So at a time we are going to read one by one element of the matrix. So in this code we have written how to read elements, read the matrix content or matrix elements we have written. So we have written how to read a matrix. Now let us write down a function that how to print the elements in the snake format. So let me write display snake pattern. So to this what we are going to pass? We are going to pass the array or the matrix of elements. So name of the matrix is mat. Okay. So with this we have written that how to read a matrix, and then we have called a function display snake pattern is the name of the function, and we have passed the matrix over here. Okay. Now, so if you want to write down this function, you can write down at the top or you can write down at the bottom. So let me write down display snake pattern. If this function returns nothing, so you can always, if this function is not returning anything, then you can write down void. Now what it receives? It receives a matrix. So name of the matrix is mat. How many rows and how many columns it is having? It is having m rows and n columns. Now how to write down the logic of the matrix? So to move through the matrix, let me take I and j are the two looping variables. Okay. Now first what we will do? We will write down in message that the matrix elements, just a message I am writing, the matrix elements in snake format. Okay. So just write down this message, and then first we will write down the logic that how to traverse through the matrix. So traverse through the matrix. How to traverse through the matrix? So for that we need to take the help of the loop. So let us write down a loop. So for I is equal to 0, how far you will traverse? So for each row you will traverse till I less than m, then I plus plus. So we are trying to traverse through the matrix. If the matrix is having number of rows, m rows and n columns are there, so we will traverse. So in each row, what we need to check whether the row is even or odd, that we have to check. So we'll write down the message, check the row is even or odd. This is what we are going to perform. So let us write down a if condition. If I modulus 2 double equals to 0. Okay. So we are now going for the ith row. Initial value of I is equal to 0. I modulus 2, if it is equal to 0, then it is an even row. So if it is an even row, then what we have to do? We have to print the elements from left to right. Okay. If it is an odd row, then you have to print the elements from right to left. So let us write down the logic for if the row is even, then how to print the elements from left to right. Okay. So for that, let me write j is equal to 0, then j less than n and j plus plus. Okay. So let us write down printf. So I am giving some spaces. So percentile 4d or 5d you can give the number of spaces that will come in between the elements, then followed by the matrix of ith row and jth column. Ith row and jth column, that will be displayed. Else Else, if the matrix is odd, then what you have to do? Then we have to print from the reverse order. So we'll write down a for loop. So for j is equal, it should come from the end. So the number of columns is n. So as the number of columns starts from 0, so the last column is n minus 1. So j is equal to n minus 1 until j greater than equal to 0 followed by j minus 1. So hope this logic is clear. So here we are trying to print from right to left if the row is odd. So if the row is odd, then j value will start from the nth row. So n value is j is equal to n minus 1 as the column number starts from 0. So n minus 1, j greater than equal to 0, j minus minus. Now printf, then your percentile, you can give some space 4d followed by your matrix of ith row and jth column. Okay, so this is about the logic of this problem, that how you are printing the matrix from left to right and right to left if it is even or odd. So let us run this program and check whether we are getting the output of the matrix in a snake pattern or not. So let us compile and run this. So first we are getting the message enter elements into the matrix. So enter elements, we have taken a 4 by 4 matrix. So 1, 2, 3, 4, then 5, 6. Let us check it again. Let us check it again. We have missed the ampersand. So we have put the ampersand now. Now let us compile and run it again. So the elements are 1, 2, 3, 4. This is the first row. Then 5, 6, 7 and 8. Then 9, 10, 11, 12. Okay. So we have entered a 4 by 4 matrix. Now our output is not coming. So let us check what is the problem that output is not coming. So to get the output, let us first check. So first we have read the matrix, m by n matrix. Then we are reading for I is equal to 0, I less than m, I plus plus, and we are reading the matrix for ith row, jth column. Then we are calling the function display snake pattern and we are passing the matrix. Okay. So matrix reading part is perfectly fine, and then followed by, let us go for the logic. So in this we have taken m is equal to 4, n is equal to 4. Okay. So number of rows and number of columns both are same. So 4 rows and 4 column matrix we have to read. So we are reading a 4 column matrix. So let us check the logic of the problem. So we have taken 2 looping variables. Now we want to print. So first we are traversing through the matrix. If I is equal to 0, I less than m, then I plus plus. If I modulus 2 is equal to 0, then that row is even. So we are printing the matrix content. So j plus plus matrix of ij. Otherwise, we are printing from n minus 1 till j greater than equal to 0, j minus minus matrix of ij. So let us rerun and check the output. So let us give the content 10, 20, 30, 40. Then followed by 50, 60, 70, 80. Okay. Then give 15, then 25, suppose 35 and 45. Then followed by, let us give 100, 110, 120, 130. Yes. Now the matrix elements in snake format, just observe the first row. First row is even, so 10, 20, 30, 40 is the output. Second row is odd, so it is coming in the reverse order, 80, 70, 60 and 50. Third row is even, so 15, 25, 35 and 45. And the fourth row is 130, 120, 110 and 100. So if you will observe this output, you can find the output is in snake format. So this is called the problem using snake format. So you can simply display the output over here. You can copy paste the output, and this is the required output for this problem. So let us move on to the next problem. Now we shall discuss about another problem, which is called difference between sum of elements of two diagonals. Suppose you have a matrix. So in that matrix, find the sum of the left diagonal and the right diagonal and find the absolute difference of the sum. So we are given a n by n matrix over here, and our task is to calculate the absolute difference between the sum of its diagonal elements. Okay. Now, if you will look at this matrix, that this matrix is a 3 by 3 matrix. Now, in this 3 by 3 matrix, so sum of these diagonals we have to find it out. So, this is our, let me take, this is our left sum and this is our right sum. If I am talking about, this is our left sum, L sum, let me take, and this is our R sum. Now, what you have to do, first you have to sum your left diagonal element, left sum you have to compute. This is L sum and this is R sum. So, left sum is nothing but the elements 11 plus 5 plus minus 12, which comes to 4. Similarly, the right sum is 4 plus 5 plus 10, which comes to 19. Okay, this is 4 and this is 19. Now, here we have to find out the absolute difference. So, absolute difference is nothing but this left sum minus right sum. Its mod. So, which is nothing but mod of 4 minus 19, which is nothing but 15. So, in our logic, what we are going to do, after computing the left sum and right sum, we'll check if the left sum is less than the right sum. Here our L sum is less than the right sum. Then what we will do? We will simply do R sum minus L sum to get our absolute difference. If our left sum is bigger than right sum, then we'll simply do L sum minus R sum. So, this way we can find out the absolute difference. Otherwise, whenever you do programming, we'll take the help of ABS, which is there in math.h, so which will compute the absolute difference between the two elements. So you can see over here, there is another matrix of size 2 by 2. Now here, 10 plus 5, left sum is 10 plus 5 is 15, minus 4 plus 2 is 6. So, the answer is absolute sum is 9. Okay. So, let us write a program to find the difference between the absolute sum of two diagonals. Okay. Now, let us start this program. Now, to find out the absolute difference, so first you have to read a matrix. So, as in the previous program, we have already read one matrix. So, we can copy the code of the same thing and we can read the matrix in the similar manner. Okay. So, here we will take, to find out the absolute difference, we have to take a square matrix. So, instead of making it, I am taking a matrix of size 10 over here. Okay. So, then we will read the matrix. So, for reading the matrix, we need to read the number of rows and number of columns over here. Okay. So, first read how many rows and how many columns matrix you need it. So, for that, let us write like this. Enter the number of rows and columns for the matrix. We have taken a 10 by 10 matrix, but for our example, we may take a 2 by 2 matrix or 3 by 3 matrix. We can take. So, let us read the number of rows and columns. So, for that, let us write scanner %id and it is ampersand R and ampersand C. Okay. So, after reading the number of rows and columns of the matrix. Then read the matrix. So read the elements of the matrix. So we will change this to number of rows and we will change this to number of columns. Okay. And we are reading the elements of the matrix. Now here the question is to find out the diagonal, the sum of or difference of diagonals. So just this is the function name, difference of diagonals I need to find out. Now for this what I need to pass. So I need to pass the matrix followed by I need to pass how many rows and how many columns I have. So R and C values also. Now let us write this, the function code. So what is the name of our function? It is difference underscore diagonals. So if the matrix returns nothing, then write void difference underscore diagonals. And then what it takes a matrix. So matrix of size 10, 10 we have defined, followed by we are passing number of rows int r comma int c. So we have written the definition, the skeleton function we have written. So the name of the function is difference underscore diagonals and we are passing a matrix and we are passing the number of rows and columns. Now how to find out the sum of its diagonals? So for that let us take a variable I followed by to find out the two diagonals. So suppose first diagonal is D1 and second diagonal is D2 and both are initially 0. Okay. Now as this is a square matrix, let us write down the for loop for I is equal to 0, then I less than the number of rows, then I plus plus. Then how to compute the left diagonal sum and then the right diagonal sum. So how to compute D1? D1 is equal to initial value of D1 plus the left diagonal is nothing but, if you will consider, then it is 0, 0, that is 0th row, 0th column value, first row, first column value, second row, second column value, and third row, third column value, if it is a 4 by 4 matrix. So the left diagonal elements are nothing but where the index position of I and j both are same. So 0, 0, 1, 1, 2, 2, 3, 3, these are the index positions of the diagonal elements. So based on that logic, we can simply write it is I and your j, that is both are same, so I of I. So this is left diagonal sum. Now coming to right diagonal, now it is D2 plus the matrix of. So whenever it is coming to the right diagonal, so in a matrix you will go to the end. Okay, so that value is nothing but for the ith row, the column is nothing but the C is the number of columns. Okay, suppose number of columns is 4, so it is 3. So C minus I minus 1. So it is C minus I minus 1. Okay, so this way we are computing the left sum and right sum. And what we are going to do, we are going to return the absolute value of this D1 minus D2. So ABS is a built-in function that we can write it. So this ABS function is available in the math.h header file. So let us write hash include stdio.h, then hash include math.h. Okay. Now our program returns the absolute value of D1 and D2, which is an integer. So write down here int. So in the function returning some integer value. So how to display that value? Display that absolute difference. So whenever you are calling the function, we can write down one printf statement over here to print the absolute difference. So we can write down the absolute difference of sum of diagonals is percentile d, comma. We have called the function over here. So we'll go to the end. Okay. So this way we can print the sum of diagonals. So let us observe the code how we have written. So D1 and D2 are the two diagonals. So two variables to store the sum. So for the matrix, we are traversing. This is nothing but traverse through the matrix. Now while traversing through the matrix, first we are computing D1. D1 is nothing but the I through ith column. That means the index number of the diagonal elements from left to sum. It is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4 and so on. So matrix of ith row, ith column. Okay. Now whenever you are coming to write diagonal sum, then you in the first row, suppose if it is the 0th row, then go to the your nth column and from there you have to display. So it will be starting from C minus I minus 1. Why? Because first time, suppose C is equal to 4. Number of columns is equal to 4. So, as it starts from 0, so it is the third column value. So, C minus I, C minus 0 minus 1, it is 3. Second time, it is reduced, one column is reduced. So, C minus I minus 1, this will keep on doing until you go to your 0th column. So after finding the sum D1 and D2, then you return the absolute value of D1 minus D2. So the absolute difference, you can write simply a if condition. So if D1 is greater than D2, then you have to, then D1 minus D2 you have to do. Otherwise you have to do D2 minus D1. So this logic, instead of writing this logic, you can simply use the absolute function also, which is available in math.h. Now let us go run and see the output. Now enter the number of rows and column of the matrix. Let us take a 3 by 3 matrix. So 9 values you have to enter. So 1, 2, 3, then 4, 5, 1, then 2, 1, 2 or 3 suppose. So the absolute difference you can observe over here. The left sum is 1 plus 5 plus 3. So it is 9 minus. So 3 plus 5 plus 2. So it is 5, 3, 8 plus 2 is 10. So 9 minus 10, the absolute difference is 1. Okay. So the answer is absolutely correct. So let us go for another example. So you can check it with different test cases. So let me paste the output over here. Now let us go for another example. So let us rerun the program and check the output. Let us take a 4 by 4 matrix. Okay. So 4 by 4 rows, 4 columns. So it is 1, 2, 3, 4 for example. Okay. Then 2, 3, 1 or 4, 1. Then 5, 6, then 4, then 2, then 4, 3, 2, 3, 1. Now, what is the absolute difference you can compute? 3 plus 1 left sum. 3 plus 1 is 4, 4 for 8 plus 1 is 9. Then this side it is 4, 4, 8, 8, 6, 14, 14 plus 4, 18. Okay. So, the difference is 9. 9 minus 18 is 9. So, whatever example you will take, for different test cases, the output is correct. So, this is about the second problem where you are finding the absolute difference of the sum of diagonal elements. Now, let us discuss about the third problem, that is called automorphic number. So, the third problem is regarding automorphic number. What is an automorphic number? Suppose a number n is given. So, your task is to check whether the number is automorphic or not. So, what is the logic for automorphic? A number is said to be automorphic if and only if its square ends in the same digit as the number itself. So, this is called automorphic. Now look at this example. If n is equal to 76, whether this number is automorphic or not. So for that, you find out the square of this. So the square of 76 into 76 is 5776. Now, if you will see the last two digits, it contains the original number itself. So this is an automorphic number. Let us take another example, 25. 25 is also automorphic. Why? Because first you find out its square. 25 into 25 is 625. And if you will observe the last two digits, then it contains the number itself. Now, coming to 7. 7 is not automorphic because 7 into 7 is 49 and the last digit is not containing the number 7. So, it is not automorphic. Now, how to do this problem? Let us try it. Okay. So, let us go for, so how to do automorphic number. So, first write down hash include stdio.h. So, for after writing the structure, let us write down the logic. Now, first of all, what you have to do? First of all, you have to read a number. Okay. So, let us take a number n. So, printf, enter a number. Scanner, then %id, ampersand n. So, this is called reading a number is over. After reading a number, we will use a method or function called is automorphic. So, we are using a function called is automorphic. If it is automorphic, then we print that it is automorphic, otherwise not automorphic. So, is automorphic, this will give the number, we will give the number n to this, and if it is returning 1, then it is automorphic, otherwise it is not automorphic. Okay, so based on that, we will write down a ternary operator over here, that if it is returning 1, then it will print automorphic. Similarly, colon, if it is returning 0, then it will print not automorphic. So, hope this logic is clear. So, here we are simply reading a number n and then we are calling a function called is automorphic. So, we are passing the number n. So, if this function returns 1, then it will print that it is automorphic. If this function returns 0, then it will print not automorphic. Okay. Now, let us write down the function. Now, this function is returning me 1 or 0. So, int is automorphic is the name of the function. Okay. So, what we are passing? We are passing the number. So, int n. Now, what is the logic? First, we have to find out the square of the number. So, let us take a variable int square is equal to n into n. So, square of the number we have got it. Now, till the number becomes 0, so till n greater than 0, we have to write down our logic. So, what is the logic? That the last digits of the square should be the number itself. Okay. So, for that, we will check if n modulus 10 is not equals to square modulus 10, then return 0. What do you mean by this? The number modulus 10 will always give you the last digit of the number. Similarly, the square of the number is a bigger number. Modulus 10 if you will get, then it will also give you the last digit of the number. So, if the last digit of the original number and its square, if both are not matching at all, there is nothing to check further. So, you can simply return 0. Okay. If they are matching, then again, if it is a 2-digit number, then you have to repeat the process for 2 times. If it is a 3-digit number, you have to repeat the process for 3 times. Then check for the next number. So what you will do? N is equal to n by 10 and square is equal to square by 10. We will repeat the process. Okay. So next time also it will check whether the number is greater than equal to 0 or not. If it is non-zero, then again it will find out the remainder, the last digit, and it will check the last digit of its square. Are they matching? Then again repeat the process. If the number becomes 0, then this process will be completed. Okay. So this is the logic of the problem. So let us compile and run this. Now enter a number. So we have checked that 25 is an automorphic number. So we are getting the answer as automorphic. Let us check with 2-3 test cases. Now, if you will take a number 76, then you have seen that it is automorphic. Yes, it is automorphic. And let us take a number 7. Then its square is 49, which is not automorphic. So like that, you can take any example and you can check whether it is automorphic or not. So you can take any number and check. So if I am taking 5, then its square is 25. So the last digit contains the original number. So it is automorphic. So today's class is about the automorphic number problem, and let us go for the last problem regarding the Armstrong number. Now, what is an Armstrong number? Now, in mathematics, a n-digit number is said to be Armstrong if the sum of its, suppose if it is a 3-digit number, sum of its cubes of individual digits is the number itself, then it is called Armstrong number. If it is a 4-digit number, the sum of its, every individual digit's fourth, okay, is the number itself, then it is called also an Armstrong number. So this is the mathematical definition of an Armstrong number. So let us see some examples. So an Armstrong number is a number that is equal to the sum of the digits raised to the power total number of digits in the number. Okay, examples of some of the Armstrong numbers are 153, 370, 371, your 407, 1634 and so on. So you can see that 153 is 1 to the power of 3 plus 5 to the power of 3 plus 3 to the power of 3. So if you will sum it up, then you will get the original number itself. Okay, like that for 370, for 371 and so on. There are a number of Armstrong numbers available. So how to write down its code? Let us check it. So to write down the Armstrong number also, first of all you have to read a number. So let us go for how to read a number first. So after reading the number, let us call a function Armstrong and pass the number. Now, let us write down the logic for Armstrong number. Now, the name of the function is Armstrong. So, write int Armstrong. We are passing the number. So, int n is the number and we will find out the sum. So, let us take one sum variable. Initially, sum is equal to 0 and take one looping variable or reminder variable r. Okay. Now, while the number not equals to 0, we will repeat this process. So, every time we will find out the remainder. So, r is equal to number modulus 10 will get you the remainder. Then sum is equal to, or sum plus is equal to, so do it r into, so I am doing this logic for 3-digit number. You can generalize for any digit number. So r into r, so r cube I am finding out here. Okay. Now Again, do it num is equal to num by 10. This process will be repeated until the number becomes 0. Every individual digit it will find it out and it will cube it up and then sum it. If this logic will work for 3-digit numbers. Now after getting, you have to let us return the sum. Okay. Now this sum we will compare with our original number. So after reading the number, I am taking one temporary variable. So in that I have stored the original number. Okay. Now the Armstrong number is returning the sum. So let us compare this sum with our original number. So by writing in simple if condition, if your sum is equal to 10, then printf the number is Armstrong, otherwise number is not Armstrong. So this is the logic for Armstrong number. So save and run the program. Take any number. Let us take a 3-digit number 153. So 153 is Armstrong number. Similarly, let us take a number 125. So it is not Armstrong. So in this video, we have learned a number of problems we have learned using functions. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.